Hi, hello everyone. So, what we're going to have a look at today is we're going to introduce the concepts again of sine, cos, and tan. Now, you would have done these at Junior Cert and the theorem of Pythagoras, so I'm not going to dwell on it too much. Just to give you a quick review of it. Okay, so in a right angle triangle, okay, A, B, and C. If A is the longest side, then the length of A squared is equal to the length of B squared plus the length of C squared. Okay? And you can rearrange that to find any of the other two using square roots and stuff like that. So that's Pythagoras' theorem. Okay? So how does this apply to sine, cos, and tan? Well, the ratios of the lengths of the sides is a constant ratio that can be attributed to a particular formula. So again, take a right angle triangle, okay? And this is probably an important thing. You need a reference angle. This will be the angle from which you reference your sine, cos, and tan. So in this case, we'll call it theta, okay? So if this is theta, then the side directly across from it is called the opposite side. Okay? The side across from the right angle, in other words, the longest side, is called the hypotenuse. And then the third side, the side that's not opposite or hypotenuse, is called the adjacent. Okay? And the sine of theta, the ratio of sides that would give you the sine, is equal to opposite over hypotenuse. Okay? Similarly, the cosine of theta is adjacent over hypotenuse. And the tan of theta is equal to opposite over adjacent. Okay? So that you would have done that for the junior cert. There's nothing kind of, crazily new in that, in fairness to it. So I'll just do a quick one or two examples just to show you this in the real world so that you're totally okay with it. So here's a right angle triangle, and here is theta, and here is alpha. So we have two reference angles. I'm just going to put some numbers on these, okay? Just to make, things a little bit easier, I suppose. We'll call this side 3. We'll call this side root 5. And we'll call this side 2. Okay? Cool. So, let's find the sine of theta. Let's find a different color here. Sine of theta. And we'll also find the sine of alpha. So the sine of theta is always going to be opposite root 5 over hypotenuse 3. The sine of alpha is going to be opposite 2 over hypotenuse 3. The cosine of theta is going to be adjacent 2 over hypotenuse 3. The cosine of alpha is going to be adjacent root 5 over 3. And then the tan of theta is going to be opposite over adjacent. And the tan of alpha is going to be opposite over adjacent. Okay, so that's just a quick how you would get it. So what are you actually getting? I suppose that's the thing. You're not finding the angle, but you are finding the ratio of sides that angle makes. if you know what I mean. So whatever that angle makes, the sine of that angle makes that ratio of sides. So that's what you're trying to get. But it does allow you to do something, okay? Very importantly, it does allow you to kind of work backwards. It allows you to find the angle from the ratio, okay? And we're going to show that now in a second. So it's not that hard, the maths. Again, it's all junior cert stuff really up until now. We're just going to kind of apply it to kind of leaving cert scenarios, but it is really all junior cert stuff. So where do we get into the real detail? Well, the first thing is we get out Mr. Friend, the calculator, okay? So very importantly, make sure it's on D for degrees, okay? Because we're using sine, cos, and tan of degrees. Now, when to know to use degrees and radian, my rule of thumb tends to be if you're presented with something in terms of pi, use radians. If you're presented something that doesn't contain pi, use degrees, unless it's specifically stated, okay? That would be my kind of logic on it, okay? Pi tends to be associated with radians. So when you see a pi in a trigonometrical scenario, you're usually dealing with radians unless they're specified otherwise, okay? So why are we going to use the calculator? Well, we're going to show how to move between the sine and the angle and the angle and the sine, okay? So what we'll do is we will start with some of the ones that we had previously. So if you bear with me here. So sine of the angle is root 5 over 3. So how do I find the angle? Well, get your calculator, okay? Get your calculator. You see it there? So if the sine of the angle is this, well then you divide both sides by the sine. So sine divided by sine is just 1, so that's theta, is equal to the sine inverse. Remember, to the minus 1 is the division, it's 1 over root 5 over 3. So on your calculator, you do shift sine and you get the inverse function for sine. You can see it there. Okay, then you just type in what you have, root 5 over 3, close the bracket, and press your equals. Now, it's going to give it to you in decimal form. If you want it in degrees form, you press this button here. Okay, I'll show it to you. This button here. Okay. Very hard to see there. It's shining. It's like a circle with 3 commas beside it. If I press it, you'd see it when I press it, okay? Watch when I press it. Suddenly now it's 48 degrees, 11 minutes. Okay? And then 22 seconds. Okay? So if you're asked to convert it, usually I would leave things in decimal form. But if they ask you to the nearest degree or to the nearest minute or to, you know what I mean, then you can use that conversion on your calculator to do it. Okay, we'll do it with another one now just to give it a go. Okay. So let's do the cos of the angle is root 5 over 3. Why not? Okay. So let's have a look at this one. Same thing again. The angle is going to be the cos inverse root 5 over 3. Shift, cos button, fraction, square root 5 over 3, close bracket. Theta is 167. Oh, sorry, made a mistake there. Ignore. I put a 4 in front of it. How the hell put a 4 in front of it? Just delete that. 41.18. So it's 40, not too bad. Sorry. 41.81. And if I want to do that in degrees, That's 41 degrees, 48 minutes. Okay? So that's how you do it. You can do the same for tan inverse. Okay? So that's how you convert the ratio back into the angle. Okay? To turn the angle into the ratio, it's pretty easy. Watch. Sine of 48.189 is 0.7, which is what that is. No, it's actually what that is. I'll try it. Sine our cos of 41 degrees, 48 minutes. Sorry, 48 minutes is, and that's what that is. You know, it's the same answer because it is what it is. So it actually does work. It's pretty cool. Okay. So that's it. That's how you use your calculator. Okay. Just be aware of this. Okay. Just be aware that you can use your calculator to reverse the process of, you know, turning cos into the angle and angle into the sine, cos, or tan at that angle. Okay. Now, there are some very special angles that we don't use the calculator for. So I'm going to bring you back to our old friend, Mr. Log tables. Okay. And you can see them here. Okay. 0, 90, 180, 270, 30, 45, and 60. If you want the sine, cos, or tan of them, they're actually here. Okay. I'm going to kind of shade them green for you. There they are, those ones. Top line, this line is the radians. This line is the degrees. But there's the sine, cos, and tan of each of those degrees or radians. Okay, so as you can see, the cos of 0 is 1. The sine of 0 degrees is 0, and the tan is 0. Then you get 0, 1, nothing. Then you get minus 1, 0, and 0. 0, minus 1, nothing. And then you get the fun ones. The cos of 30 degrees is root 3 over 2. The cos of 45 is 1 over root 2. The cos of 60 is a half. The sine of 30 is a half. The sine of 45 is 1 over root 2. And the sine of, you can see what's happening here. They're actually just the opposites. And the sine of 60 degrees is root 3 over 2. And then similarly, tan of 30 is 1 over root 3. Tan of 45 is 1. Tan of 60 is root 3. So these, I would say, even more importantly, these are the kind of ones that come up like so frequently. Okay, which is why I'll kind of always kind of come back to them a good few times. They are quite important. This page is monumentally important. So many things on this page that are important that you need to kind of keep an eye on, and we will as we move our way through it. Okay, but for today, you know, be familiar with the fact that sine, cos, and tan of those special angles, you don't use the calculator. Please don't. Okay, because you will get it. Won't get the wrong answer, but the answer you get in the calculator will not be the same answer as this, and it will make it harder for you to do sums. Trust me on this. So for just those 3 angles, be aware, do not use the calculator if possible. Okay. So that's just a little kind of an aside on that, just to kind of get your head around it. So let's do some fun things then. Let's have some fun. So here's some really cool ones. This is where this looks a bit freaky and crazy, but this is actually pretty cool. So, without using the calculator, we're going to try and figure this out. So, the sine squared of pi over 6 plus the sine squared of pi over 4 plus the sine squared of pi over 3. When I add the 3 of them together, what do I get? Okay, so the sine squared of pi over 6 plus the sine squared of pi over 4 plus the sine squared of pi over 3 gives me what? Now, first of all, you're thinking, well, what does sine squared means? Right. Sine squared of an angle is you get the sine of the angle and you square it. Remember, the sine of the angle will be a ratio. It'll be a fraction. So you're just squaring a fraction, basically. Okay? So I suppose what you have to decide now is a few minutes ago, what did I mention about when you see something that has pi? That's right. These are in radians. So we're going to go to our page and we're going to see where's pi over 6. Well, pi over 6 is there. So what's the sine of pi over 6? It's a half. So that really means that that is a half squared plus pi over 4. Let's go to pi over 4. Pi over 4, the sine of it is 1 over root 2. 1 over root 2 squared plus sine squared pi over 3. Pi over 3, get the sine of it, root 3 over 2 squared. Root 3 over 2 squared. Okay, we're not using a calculator here, so let's try and do it. So, what's it going to look like? Give me a second here now. I'm just going to get a piece of paper. Cover that. So, a half squared is a quarter. Plus 1 over root 2 is a half. Plus root 3 over 2 is 3/4. So a quarter and 3/4 is 1. 1 1/2, which is 3 over 2. So it's 3 over 2. You see that, lads? So nothing to be afraid of with these once you actually know what you're doing. So that's like, it's a pretty cool. I think it's pretty cool anyway. Some people mightn't think it's cool, but I personally think it's very cool. We're going to use a lot of these trigonometric identities as we go forward, but there's just a nice little example of how to use it. We'll do another one or two. Okay. So if the sine of A is equal to 3 over 5, find the cos of A and then find the angle A. So if the sine of A is 3 over 5, find the cos of A and then find the angle A. Okay, but how would you do this? I would do it thusly. First thing I would do is I would sketch a right angle, triangle, throw in my right angle. Put in A wherever I want. Put it up here. Okay, so what does A say? The sine of A is 3 over 5. That's opposite over hypotenuse. Opposite hypotenuse. How would I find the cos of A? I need adjacent over hypotenuse. So what have I got? A right angle triangle. Right angle triangle says that 5 squared is going to be equal to 3 squared plus whatever that is. We call it x. X squared. So 5 squared minus 3 squared is equal to x squared. X is equal to the square root of 5 squared minus 3 squared, which is 4. Which is 4. So x is equal to 4. So now the cos of A is equal to 4 over 5. And A is equal to the cos inverse 4 over 5. Cos inverse of 0.8. I'm going to give it in degrees form. Sorry, degrees form. 36 degrees, 52 minutes. Right. So, sorry. Hope that helps you. So that's just a little introduction. Like most of that stuff you would have done third year. I'd say last year. Some of you it was last year, some of you it was third year. But that's a little introduction into how to do it. So we're using very simple things like Pythagoras to get missing sides, and then just our simple trigonometrical ratio and using the inverse ratio to get either the angle or the ratio itself. Okay? All right, listen, thank you very much. I'll see you in the next video.